อาจารย์ครับ
ครับผม
อาจารย์ครับ can you accept my friend she waiting you in the waiting room thank you ครับ
Hey. Yesterday we start by talking about vectors and some properties of vectors. Okay, let's review what we learned yesterday. Okay. A vector is a quantity that having both magnitude and direction. So in order to get the magnitude, sometimes we represent vectors by a pictures of an arrow. The magnitude of vector is represented by the length of the arrow, and the direction is by the way that the arrow aligns compared to the reference axis. Let's say that. And the symbol for vector is a capital letter or small letter with the arrowhead on top. And we read that vector of A. Now, with the letter without the arrowhead on top is the magnitude of A. Or sometimes you put an absolute sign into it. Now, special vectors of A is A with something like a pointy hat on top. This is called unit vectors of A. It is the vector that have the same direction as A, but with the magnitude of 1 unit. And the most important vectors of the vectors of unit vectors is the unit vectors along the x-axis, the y-axis, and the z-axis. And usually we have x hat, y hat, and z hat to represent that, or sometimes we use I, j, and k. And this is called the Cartesian coordinate or the rectangle coordinate. Now the two vectors will be equal when it have the same length or the same magnitude and pointing in the same direction. If the vector have the same magnitude but point in the opposite direction, we say that it is a negative vector. Now to add it in pictogram, the way we add the vectors is that we put the second vector at the end of the first one. So d1 plus d2, we have d1 and then put d2, the origin of d2 at the beginning, at the ending of d1, and then the vectors that starting from the origin of the first vector to the end of the second vector is called the additional vector. And by this, we immediately saw that this one having a commutative properties, means that d1 plus d2 equal to d2 plus d1. You can switch it, substitute it by the other. Okay, so it's have commutativity. And then it also have associativity. So you can group it into small group. A plus B plus C, you can group it into B, A plus B, and then plus C. Or you can group it to be A plus C, and then plus B. or you even can group it to B plus C equal to A, plus A later. It has the same resultant vector. So for addition, you have both commutativity and associativity. Now the opposite vector, opposition vector, is a vector that points in the opposite direction. Now if A is addition to the opposite vectors of B, we write that as A plus minus B. It is the same as A minus B. So the subtraction of the vectors means that the first vector was added by the opposite vector of the second one. So this is A, and if this is B, the minus B is in the same direction, opposite direction, but the same length. So we see that A minus B is this way. So A minus B is the blue one and A plus B is the black one. And you see that it doesn't have a commutativity. So A minus B is not equal to B minus A. And because you can break any vectors into two vectors addition. So if you have any vector A, you can break it into two. And the very important pair is when the two vectors are perpendicular to each other. So we have vectors A, and then we break it into AX and AY that are perpendicular to each other. AX is the one pointing into the X axis, and AY is the one that pointing in the Y axis. And you will see that these three vectors form a right triangle. So you can use Pythagorean theorem, say that AX square plus AY square equal to A square. And then you also can use the relation of trigonometry that AY, which is the side opposite to angle theta, divided by the hypotenuse, which is A, the magnitude of the total vector, equal to sine theta. And the magnitude of AX, which is the adjacent side of the angle theta, divided by the hypotenuse A, is cosine theta. So you can see that we can break any vectors into two vectors that perpendicular to each other. And AX is A cosine theta, and AY is A sine theta. So I will skip that sine and cosine back to component vectors. So by doing that, let's see, we can distribute any vectors in Cartesian rectangular coordinates in terms of 3 unit vectors. Because we have unit vectors along the x-axis, we call it I. And unit vectors along y-axis, we call it j. And unit vectors along the z-axis, we call it k. So any vectors can be break into 3 vectors addition. The first one is the vectors that pointing in the x-axis, we call it AX. And then the another vectors that pointing along the y-axis, we call that AY. And then another vectors that pointing along the z-axis, we call AZ. And the difference between these 3 is that the magnitude. So because AX is always point to the x-axis, so the magnitude of AX is how many times of the one unit vector along the x-axis. So AX can be written as AXI. Now this AX is a magnitude. Okay. and then AYJ and AZK. This is vector A represented in rectangular coordinate. And it makes this easier to do an addition or subtraction, okay, by just add them up. So if you have A in rectangular coordinate, write as AXI plus AYJ plus ACK, and B as BXI plus BYJ plus BCK. Now, the addition vector to be A plus B will be AX plus BXI plus AY plus BYJ and plus AC plus BCK. And the minus sign A minus B is AX minus BXI plus AY minus BYJ and AC minus BCK. And you will see that the commutative properties for addition hold AX plus B, A plus B equal to B plus A. However, if you're doing the B plus A, you will see that it is negative of A plus B. So it's not commute for subtraction. Now, we come to the topic of today before we have a quiz at the end of the class, which is the scalar product and the vector product. So vectors have a summation and the subtraction properties. It must have the properties of multiplication. However, because vector has two components, it has magnitude and it has the direction. So when we say multiplication, there are two ways of answer. The one that multiply after multiplication, you get a scalar product. And or the one that after multiplication, you have the vectors product. So we call the scalar product a dot product. So A dot B is called the scalar product. And A cross B is called a vectors product. Now we'll start with the first one. A scalar product is a projection of one vectors along the other vectors and then making a multiplication. So A dot B, it means that it's A times B in the direction of A, or it's B times A in the direction of B. So suppose A and B have a magnitude of A and B and making an angle phi between the two. So B in the direction of A can be break into B cosine theta. So you have A times B cosine, not theta, cosine phi, or A in the direction of B is called A cosine phi times B. So in addition, a scalar product is of A dot B is A times magnitude of A times magnitude of B times cosine phi. Now this is very useful when you are working with the work and energy. So by definition, the work is a force along the direction of motion times the distance that it's moved. Or in that case, when we say force in direction of motion times the displacement, we are talking about dot product because one vector is breaking into another vector direction. So this is very useful to use in work, to find work and to find energy. Okay. So This is the same thing, A times B. And in rectangular coordinate, you see that unit vectors I and J are pointing in perpendicular to each other. So if the vectors are perpendicular to each other, the dot product will become 0 because it doesn't have any direction it doesn't have any magnitude in the direction of another vector. So we can conclude that I dot I is 1, J dot J is 1, K dot K is 1 because it's multiplied to the same vectors. However, the cross one, the I dot J or J dot K or K dot I is 0. Why do we talking about this? When you're doing a rectangular coordinate, you make A dot B. All you have to do is distribute the unit. So A dot B, you have AXI times BXI. So I dot I is 1. And AXI times BYJ. Now I dot J is 0. So what you have left for the scalar product is that if you have a vector A represent in rectangular product as AXI plus AYJ plus ACK, and B as BXI plus BYJ plus BCK, and you're making a scalar product between the two vectors, what you got is AX times BX plus AY times BY and AC times BC. And this is called scalar product because the answer come out as a scalar. It doesn't have a vector. So now there are another product is called vector product, and we use the symbol cross or look like an X. So A cross B, well, by definition, is another vector. A cross B times is another vector pointing perpendicular from both A and B. So if you have A and B in a plane, something like this, you see that the resultant vector should be either going up or down. Now, the direction of the resultant vector is according to right-hand rules. So if you put your hand to A and roll it towards B, what you got is downward. So you have A times B. The resultant vectors pointing downward. And the magnitude of cross product is defined by a vectors times the magnitude of vectors that are perpendicular to the other. So A times A cross B, the magnitude of it is either B times vectors of A that perpendicular to B, or B or A B times A that is perpendicular to B. No, just start to confuse. It's A times B sine phi or B sine phi times A. That's the magnitude. So another way is that if you're doing a right-hand rules, you see that A cross B is not equal to B cross A because it have the resultant vectors that both are perpendicular to A and B, but they are point in the opposite direction. So here's the pictures of the right-hand rules. You see that the first one, vector A is this way and vector B is this way. So you point your finger, both four fingers towards A and making a fist by rolling it up to B. Now stick your thumbs out and you see that the direction of the thumbs is the direction of the cross product. Now, if you cannot roll your hand by that, you have to flip your hand by 180 degrees and then making a roll. And in that case, you see that the thumb is quite downward. So the first one is A cross B. The second one is B cross A. That's point in the opposite direction. Now, for example, this A is along the XY plane. Okay, making angle 250 degrees to the x-axis. And B is along the z-axis. So the cross product between A and B is going to point this way. Okay. A cross B, you point your fingers towards A and you roll it up towards B, and your thumb is and that thumb is pointing along this axis. And this is called C equal to A cross B. Now, because A and B are perpendicular to each other, according to the pictures, so magnitude of C is actually magnitude of A times magnitude of B. Now, if it's not perpendicular, magnitude of A and B will be times cosine sine of this angle. And in rectangular coordinate, we can see that by doing a cross product, you see that I cross I and J cross J and K cross K is all result in 0 because they are pointing in the same direction. Now, however, for I cross J, it gives the result of K, okay, and J cross I gives the result of minus K. It is the same for another 4 pair. So what you have is that when you're doing a direct multiplication or cross product between A and B, you will get 9 terms. Out of the 9, 3 of them will become 0 because it's pointing in the same direction. The rest, 6 term, is still intact. And the way to remember that is to remember from I, J, and K, making a cyclic order. Now, in rectangular coordinate, you can do a vector product, I equal to AXI plus AYJ plus ACK, and B equal to BXI plus BYJ plus BCK. You're just doing just common multiplication, A cross B. What you get, you have 9 terms, AX, ABX, I cross I, AX, BY, I cross J, AX, BSAC, I cross K. And because I cross I turn into 0, so you have 3 terms that go to 0. What you have left is when AX times BY, I cross J, you get the K, that's the unit K. And AX times BSAT, and then I cross K. Well, get back to one page. You see that I cross K is minus K. So keep doing this until all of the 9 terms, and then rearrange the one in the same direction, I, j, and k. What you got is this relation. A cross B is AY BZ minus AZ BY I plus AZ BX minus AX BZJ and plus AX BY minus AY BSK. And this is the way to doing a cross product in rectangular coordinate. Well, many of you might find this to do by taking a determinant of a matrix that the first row will be I, J, and K, and then AX, AY, and BC, and the third row will be BX, BY, and BC. So we have A cross B is that determinant. How to find that determinant? So you take a matrix and then you write down 2 more columns of repeat the first and the second column, and then rolling down or doing the multiplication downward, I along the diagonal axis, I times AY times BC, and that is positive. Also SJ times AC BX. And then you're doing the opposite, so multiplication upward, so BX, AY, K. And then rearrange the term, you will see that it will result in the same relation as before. So I'm not sure. Maybe this one is a quiz. If it's a quiz, just consider yourself lucky. Suppose we have 2 vectors. Let's look at this example. A is to I minus 2j plus 3k. Oh, this is different. And B is minus 4i plus 5j minus 6k. Now, this is 2 vectors in rectangular coordinate. So what I want you to do is find A plus B, A minus B, and then dot product. So you see that C equal to A plus B. So you take the 2 and add it up. So AX is 1 and BX is minus 4. So the first term will be 1 plus minus 4i plus minus 2 plus 5j, and then plus 3 plus minus 6k. And the result will be 1 plus minus 4 is minus 3. So it's minus 3i plus minus 2 plus 5 is plus 3. So it's plus 3j, and then plus 3 minus 6, or minus 3k. So that's the additional. You can just doing it directly. So for subtraction, you're doing the same thing. Take the 2 things, subtract. You will see that now the first term, instead of 1 plus minus 4, will be 1 minus minus 4. And minus minus give the plus, so you get the 5i minus 7j and plus 9k. Now the another 2 is a dot product. So A dot B, okay, get A equal to I minus 2j plus 3k, and B is minus 4i plus 5k minus 6k. So for dot product, you take the same position. So AX times BX, AY times BY, and AC times BC. So you get 1 times minus 4 plus minus 2 times 5 plus 3 times minus 6. The first term gives you negative 4. The second term 10 plus 10. And the third term is minus 18. So -4, -10, and -18. Add them up, you get -32. And that is the dot product. Now the cross product, a little bit longer. So A cross B, you can use the formula that was given. AYBZ minus AZ BY I plus AZ BX minus AX BZ K and plus AX BY minus AY BX K. Substitute the numbers in and then work it out. We get A cross B equal to -3i minus 6j minus 3k. You can prove that it is perpendicular to both A and B by taking these vectors and then you take a dot product versus A and B. You will see that it will give us a 0. Okay. Let's do a check out a little bit. Would you please check in that you are here? And let's see if we will have a quiz later by the end of the class. So let's take a 5-minute break while you're doing this, filling this form. Okay. There is a question that in exam we will given the formula for scalar and vector product. I think normally for BTech they give the formula sheet, not only the formula for scalar and vector product. I think they also gave the formula for everything. I personally do not quite agree with that, but for me, the way I did is I allowed you to have a sheet of paper to write anything you like to take into your exam. So this comes to another question. Will we have an on-site exam, or do we have to stick with the online one? Because frankly speaking, I don't quite like the online exam. It has too many loopholes on the system. And considering that we will have our midterm exam around the first week of March, I hope that the COVID situation is good enough by that time to have an on-site exam. But we will see. But in any case, the formula will be given, or there will be another way to make sure that you can have your reference that you need. Okay. Now, there are another small things before we get back to physics. Okay. It's called the basic calculus. This course is, we can call it a calculus-based physics. This means that at some point we require the use of calculus to solve the problem. And the two important tools in calculus that we spent a lot in this class is the differentiation and the integration. Now, to put it simply, the differentiation is the rate of change of y compared to x. So in order for two variables, okay, and the integration is the sum of value of y over the region of x, or the area under the curve between y and x. So we talking about two things. Now the differentiation is the rate of change of y compared to x. So suppose we have the graph of y and x in any shape, and you see that the change of x from x1 to x2 results in the change of y from y1 to y2. So the rate of change is delta y divided by delta x is the change in y when x is changing. However, what we need is the rate instantaneously at some point. So we want to change the x by very small number. So we take the limit of delta x approaching to 0. So let's taking this to be a very small segment along the curve that approaches 0. So take limits of delta y by delta x, then delta x equals 0 is called the differentiation of y compared to x. So we write it as dy by dx or using the symbol y prime. So we can say that dy by dx is limit of delta x approaching 0 of y of x plus delta x minus y of x divided by delta x. Now, this rate of change having several relations. For example, it's right here. For exam, will be given derivative of a constant compared to x, because constant doesn't change when x changes. So that means that the change in constant over x is 0. So dc by dx is 0. Now, if it's dx by dx, y is a linear form of y equal to x. We get dx by dx equal to 1 because if the function of y changing with the same ratio of x is always constant. So we get the x by dx equal to 1. So if we take the x squared for parabola correlation, we will see that the x squared by dx is 2x. And dx cubed by dx is 3x squared. And we can sum it up to a formula state that dx to the power of n by dx is nx to the power of n minus 1. Now, if you have the exponential dE to the ax by dx, what you get is derivative of e to the ax will result in the same value. But because it have ax, so you have a up downward. So dE to the ax by dx is a equal a to the ax power of ax. If you're doing another derivative of this, we call this a second derivative. So d squared by dx squared is e to the ax is a squared e to the ax. Take a derivative of 2. Now for the harder proof, in which I will not ask you to prove in the exam, but this is you should know. But if you want to read it, what I searched in Wikipedia gave quite a decent answer of how to prove all of this. D log x by dx, this is a very special function. It's called natural logarithm. It's actually 1 over x. And derivative of sine x divided by dx is cosine x. This is the derivative of trigonometry. And derivative of cosine x by dx is minus sine x. You will see, you can by making a graph of when we take a derivative, what we are doing is a slope of the curve. So if you take a look at the sine function, you see that the slope is changing in the cosine function. And also the same thing for the cosine function, the slope will change in negative sign. And derivative of tan x by dx is actually secant square x. And there are another trick in calculus that we use a lot. It's called chain rules. Suppose you want to have dy by dx, you can change the variables to some other intermediate variables to make it easier. The intermediate variables is called u and v. So you can say that it is dy by du times du by dx by putting in the intermediate variables in between. Or dy by dx is dy by du times du by dv times dv by dx. This is called the chain rule. And this will help you when you want to do a derivative of a complex form. Well, I think there will be there is another one of this. Okay, let's check if we it's called derivative by part. Okay, it's called, it says if you have derivative of d of u times v by dx, it is u dv by dx minus by v du by dx. Okay, that's derivative by part. We will get back to it later. Now there are one more type of derivative. It's called gradient. It's called a gradient of a scalar function. And the symbol used is a reverse triangle with the vector form. The meaning of it is the gradient of any function phi is the rate of change in x direction I plus the rate of change in y direction j and the rate of change in z direction k. And you see that this d is not written the same as the one before. This is called partial differential. Sometimes we pronounce it as del. It's called the partial differential. It means that it's a rate of change in x direction by considering y and z to be zero, to be constant. Okay, so in that case, we do not interest in any change in value of y and z. Just focus on the x and treat y and z as a constant, and that is the partial differential differentiate. We use this a lot in many ways. For example, in the map, the rate of change in height or the gradient of height is actually showing the speed of the map. So, for example, this is called the equal height line. For example, you say 100 meters, 80 meters, 60 meters. So if this line are closer, means that the gradient is high and that is steep. Or you may take a look at the metal map and you see the isobar, the line of the constant of equal pressure. Okay, and that is called the gradient. So sometimes we use this in our work. Now back to integration. Integration is a area of y, the summation of y in the range of x. So suppose we have a function of y as a function of x, just like in the pictures, like this line. And then from x1 or xi initial to xf final point, this graph is having the area under from x1 to xf. And this area is called the integration of y. Because if you want to see the area, we can do it by cut it into small strips, making a right triangle. And then this right triangle has an area of y times dx. This is a small blue right angle. Then you add them up, all of them from the beginning point to the ending point. So the act of adding up is represented by the symbol of integration. So integration of dA, which is y dx, is the total area from xi to xf. So it is actually integration of xi to xf for y dx. And this is called the integration of between y and x. Here's the area from beginning to ending point. Now, some integration properties, it is the opposite to the differentiation. Now, if you integrate x to the power of m dx, you get x to the m minus m plus 1 divided by m plus 1. Because we don't have the upper and lower limit, so we have to plus the constant c. And integration of 1 over x dx is log x plus c, and x must be a positive number. X cannot be a negative number. Integration of e to the x dx is e to the x plus c. Integration of sine x is minus cosine, and then integration of cosine x is sine. Now there are some other formula on the right, but we don't use that so frequently. So I will just neglect it. If we need to use it in our exam or something, it will be given and it will be said in the question. This is something that you might want to know before you take the part of electricity and magnetism. This is used by in that thing. Okay, so we finished the first part, which is the basic math. So we are a little bit, maybe about an hour behind. So let's go ahead to the next one. Okay, someone says okay. Well, the thing is, yesterday at the end of the class, most of you already left. Some of the fourth-year students approaches and say that they have a class time conflict, so they don't have the quiz. They can't take the quiz for today. So I think that because it takes some time to accumulate the knowledge for the quiz, to have it today possibly will be too quick. So I promised them that our quiz will be on Tuesday only. So I'm sorry that I told you that we will have the quiz today and everyone getting nervous, but I decided we possibly will have the quiz on Tuesday instead, so that everyone can have a chance to take it all together. Is it okay with you, or you prefer to have it now? Tuesday is okay. Usually everyone tries to speak up as usual. Okay. Tuesday sounds good. Okay. So we will have the quiz on Tuesday. Okay. And it will be about vectors. Vectors and that calculus that we already passed. The next one will be on next Tuesday, another Tuesday, and it will be about the motion and motion in one dimension. So let's continue with our class for some time. I will let you off maybe 5 minutes before 2:30 so that you can take another class. So okay, even if we don't have the quiz, I will still do an attendance check like today on every class. So to give you some points before the midterm. Okay, so our first topic is motion, and sometimes when I was your age, this topic is called kinematics. It's some words that are sound good. Kinematics. It means that the topic of changing position of an object. So basically, it's called motion or movement. So the motion is the phenomenon that relates to changing position of the object. So it is the story of when and where the object is at some time. Now, it is considering it's about the people walking, the cars driving, the position of the car at some point, the movement of a object, and even if you watch Spider-Man No Way Home, how many of you watched that movie already? Then not yet. I suggest that you watch it because I make a reputation for myself of changing the movies into an exam. So at some particular point, I saw the potential exam in that movie. You see, the scene where MJ falling from the top of the Statue of Liberty, and then Spider-Man jumps down and catches her, is the topic of motion. You see, in order to Spider-Man to reach MJ, he can't just drop himself down from the top, while MJ is free falling down with initial velocity to be 0. But Spider-Man have to have some initial velocity, otherwise he will not reach MJ in time. So in that case, you will see that he have to jump off with some velocity. And that is a topic of motion, the thing that we are talking here. So let's get to this. My mouse is not working. It's a phenomenon that relates to changing position of the object. So first thing that we need to do when we describe motion is to give a position of the object at any particular time. So the position is the point that the object is located compared to the observer or the origin. And to locate the position, the best way is to use what we call a position vector or a vector. It tells us that the object, how far of the object from the origin and in which direction. So in rectangular coordinates, a position vector is a vector that point to the location of the object in compared to the x, y, and z. So we have r is equal to xi plus yj plus ck in rectangular coordinate. X, y, and z is a vector of the object. Now, if the object is moving so it changed position. So we have two positions now. Initial position where it starts, we use the symbol Ri. And the final position, or the position that is end, we call the symbol Rf. And when you have the original to the final, we have this is Ri at the initial point, Rf is the final point. We got two quantities out of it. So if it's a vector starting from the original point to the final point, we call this a displacement, which is blue. However, the object might not moving in straight line according to vectors and displacement. It might making a walk through the red line. This is called path of motion. So the length of the path of motion is called distance, and we usually use the symbol L. However, the vectors from initial point to final point is called a displacement, or Fs. Now, usually these two things cannot compare because the distance L is a scalar scalar quantity. It is have only the unit of length, but the displacement S is a vector quantity. It have both length and direction. So usually L is not equal to S because one is scalar and one is vector. However, there is one particular situation where the magnitude of S is equal to L. And that is when the object is moved in straight line in one direction only. So in one direction only, the length of displacement S will equal to the length of distance L. Now, let's get some example before we stop today's class so that you can take another one. Oh, sorry. Okay. Now here's the example. A student walking in a semicircle of radius r from A to B. Find the distance and the displacement of the student. Now he walking in a semicircle, and that means the distance is half of the circumference of the circle. The circumference of the circle is 2 pi r, so half of it is pi r meters. Now the displacement is a vector starting from initial point to final point. In this case, that vector S is along the diameter of the circle. So the displacement is 2r meters, have the magnitude of 2r meters, pointing from left to right. So you see that in this case, the distance and the displacement are not the same. Now, if the students complete the circle, you will see that the origin point and the final point is the same point. In that case, the displacement will become 0, and the distance will be a total circumference of 2 pi r. Another example is using, let's see another example before, because then we will have to start with the speed. An object moved from R1 equal to 2i plus 5j minus 6k. Please. Two I or 5j's and 2R2 equal to 7i plus 9j plus 10k meters. Find the displacement and magnitude of the displacement. Assume the motion is in straight line. So here's the pictures. The first one is 2i plus 5j and minus 6k. So it's 2i minus 5j. So this is plus 5j. This is x, this is y, this is z-axis. So minus 5j is half here between 4 and 6. Okay, it's here. And then minus 6k is going down 6 units. So the initial point is somewhere downward from that. This is vector Ri. And vector R2 is 7i. So here, and 9j. So this is 8 to 10, 9k. And then plus 10k. So it's going down up 10 units. So this is R2. So the displacement is the vector from initial point to final point. So we draw the displacement vector to be S equal to Rf minus Ri. So R2 minus R1. So all you have to do is doing a subtraction between two vectors in rectangular coordinate. So Rs equal to R2 minus R1. So it's 7 minus 2i plus 9 minus 5j and plus 10 minus by minus 6k. And the resultant displacement vector is 5i plus 4j plus 16k. And to find the magnitude, you're doing square of every terms and then take a square root. The magnitude of S is Sx square plus Sy square plus Sc square, and then take a square root. And you get the result of 17.234 meters or 17 meters as a result. And that's how to find the displacement and magnitude in rectangular coordinates. So a little bit later than I intended. Good luck and have a pleasant weekend. We will see each other on Tuesday with the quiz. And good luck with your next class. See you next Tuesday.
Thank you.